Hi, everyone. Welcome to our GopherCon 2020 presentation. We're excited to be here virtually in spirit with you all. Our presentation today is called Field Report, Building a Game Engine for 300 DEFCON Hackers to Smash. And I'm Alex Stockwell. I'm a security engineer by day, and I was one of the heads of development for our project here that we're going to be talking about today. And with me is my co-presenter, Kevin.
Hi, my name is Kevin Tyers. By day, I am the head of a threat intelligence team for a Fortune 250 company, which is really exciting. By night, I do all sorts of coding and I like to paint as well, which is kind of a fun fact about me. And I've been working in information security and development technology now for about 15 years. And this game that we built together was sort of a culmination of bringing a lot of different skill sets together, which was really, really cool. On this slide, you can actually see the sort of the leadership team for iCTF. There's me, Kevin, on the left. In the middle, the guy with the dreadlocks, his name is Blake Butler. He's the original founder, right, who had the idea to create iCTF. Unfortunately, can't be here with us today. And then on the far end, that is Alex Stockwell, who is co-presenting with me today. So if you're not familiar with DEF CON, it's a hacker conference that takes place in Las Vegas every year, usually in the beginning of August. This particular game that we played and we ran was on August 11th, 2018. We were originally we planned to run the game for about 6.5 hours, and that was a pretty good estimate. I think we maybe went a little long on that, but it was on a Saturday, so it was kind of a full day event for the participants. And I know at a lot of conferences you go to watch talks, but usually at hacker cons, there's a joke where people refer to them as hallway cons, where all the exciting stuff is happening outside of the talks, and usually they just watch them online later. So we had over 300 players across 146 teams that were registered to play, and we were very surprised that I think we had like 90-ish% of those people who signed up actually played our game, which felt kind of high to us, but it was really, really cool. The thing that I think drew people to play our game was the fact that we had a $10,000 cash grand prize. So the team who got first place received $10,000 in cash, and then second and third place had cash prizes as well. And when we were developing the incentive and reward structure of the game, we had thought about all these cool games that we had played, and it was always such a bummer that when you play a game and you put all this time into it, a lot of the time you walk away with nothing to show for it. So we decided to have a aggressively tiered prize system where if you got to, even some fairly easy flags, you could still win shirts and stickers and a badge to this party we were throwing and some, electronics. I actually gave away a keyboard as a hidden game within the game itself. So we wanted to have as many prizes as possible for the participants to make it worth their while to participate in our game with us. The idea behind iCTF is creating a unique and immersive capture the flag event. If you're not familiar with capture the flag events, it is essentially a scenario that is created where players have to simulate realistic, in this case will be like hacking activity, realistic information security and investigation activities to get the right answer to certain questions and then progress through the story that we had written. We always love spending a ton of money on the events and players. One of the things we're very open about is that all the sponsorship money that we get goes always into the game or into the prizes. We don't take any money ourselves. This is very much a community-driven thing for us. And I'm a huge sci-fi nerd. I love, writing like sci-fi stories or coming up with scenarios and, these different things. So one of the things I was really pushing for was creating a really cool story and that players felt like they were interacting with, right? So the story, it starts out and you're investigating this hacker who broke into a aerospace company, and then you progress through that and the stakes just get really, really high. And we wanted the players to feel like they're really participating in this and making it very, very realistic. So yeah, that was kind of the idea behind the game. So with those in mind, with those things in mind, how do we go about actually designing the experience? So the story from a high level, right, is that a hacker has broken into a company called Space Y, definitely not affiliated with like a real aerospace company. The player and their team is working with an intelligence agency, and they are being contracted to investigate who this hacker is, what do they want, do they take anything. And as they start to dig into the story, they find this deeper conspiracy involving like aliens, and they have to physically actually meet a darknet arms dealer. And eventually, towards the very end of the game, you deal with the fate of Earth and humanity itself. So, some sci-fi tropes in there, but by the time that players got to that, I think they were really bought into the story that we were trying to tell them. And on the other side of this, right, moving from sort of the fun story aspect, we wanted it to be very realistic from an actual open source intelligence investigation point of view. So we spent about a year seeding synthetic data throughout the internet, right? So we had GitHubs and real domains and websites and SSL certs, and we put up certificates and honeypots and created all these other game artifacts that are the things you would receive if you were an investigator doing this type of work. And where possible, probably 99% of the material that we created is actually still out on the internet, still realistic. You can still run through a lot of this stuff. The three areas of intelligence that we focused on throughout the game was OSINT, SIGINT, and HUMINT. So OSINT is open source intelligence, and these are pieces of intelligence you can find usually just out on the internet. Things like SSL certs, things you find on web pages, GitHub commit histories, that kind of stuff. I come from a network engineering background, so I always have to have some NetFlow in any game that I'm writing portions of. So we did a signals intelligence portion. So the players had to look at the communications between the hacker and some of his friends and the greater internet ecosystem to determine who is this person communicating with, where might they be hiding some files. And then finally, what was the most terrifying but exciting part of the game is we had a HUMINT portion, which is human intelligence. So that gentleman in the floral shirt on the right is actually my little brother, Trevor, and he was one of the 20 volunteers that we had for the game, where once the players got to a certain point, they actually had to follow people around Caesar's Palace. They had to sit at a bar with a mysterious stranger and try to get a coat check ticket, and then actually go to coat check and get them to get the jackets we left with a little bank account numbers in the pocket. So, and the thing that was most exciting about this is we didn't tell Caesar's Palace about this. So we had to get these artifacts in place the day of and the day before for the game. And it went really well, but it was absolutely terrifying to actually get this implemented. But the players loved it when they got to this point. So as we were going through this, it was awesome to have a hard deadline that we had to meet. I do very well under pressure. I'm one of those people, I can do my best coding when I know I don't have enough time. So we set out our timeline, and we knew that we had a hard stop on August 11th. We could change pretty much anything until that date, but once August 11th came, we absolutely had to be ready to go. So beyond just the seeding of the artifacts, because we seeded tons of artifacts, which we didn't even end up using, we had February and March, we're kind of thinking about ideas. April and May, we're thinking about sponsorships, finalizing the content, getting the registration sort of scaffolding of the game in place. And then June and July, it was just full speed burn on getting the game engine created. And then August 11th, we played the game. So I'll go ahead and kick it back to Alex to talk about building the game engine.
Yeah, so granted that we started with this ambitious vision where we wanted players to sort of be immersed in this story, to have sort of a common thread that they would pull and pull and pull to unravel the game's, essentially eventual end. That was threaded through each of the flags and each of the steps that they would follow. We thought about how did we want to accomplish that, or how best would we accomplish that? And so we realized that we would be looking for something in a game engine that would facilitate a lot of interactions with a lot of different teams, real-time interactions where we could drive this game on an individual basis with these players. Of course, we would need it to be resilient and secure. This is DEFCON, after all. These are some of the savviest hackers on the planet. It's notorious for having zero-day exploits and other things revealed. So we knew that people would be trying to get that $10,000 cash prize any way they could. And then obviously we would need to do the nuts and bolts of game management. So we would need to check submitted flags. We would need to maintain the state per team. We would need to be able to enroll the players, partition them into teams, validate their emails, all these things. So we were trying to scour the internet for a platform that would do this, and we really struggled to find anything even close. So that conversation led to the next logical conclusion: why don't we build it? So as we were doing this, it was basically the most informal design process ever. It was just a conversation. It was Kevin and I talking. We were the development arm of the team, and we talked about, what do we want? We want this one-on-one interactive feel with players and teams. Well, why not a bot? Why not a Slack bot? We've both written bots before. That's a great way to sort of get that interactive and almost, human element to come out. This was pre-COVID, by the way. And then in addition to that, we would need obviously the engine to power all of these bots, to power all of this stuff. And Go was the natural choice. As everyone here knows, it has a great concurrency and parallelism story. It's very performant. It thrives in these sort of client server architectures. So that was basically a no-brainer. I've been working in Go for north of 5 years. And I'd seen what it could do. So that was an easy decision. And then we went down the road of like, how are we going to actually carve this up? So we had 2 developers. We figured we'll divide and conquer. So I would take the engine, Kevin would take the bots, and we just draw a natural seam in between the work effort there. And we kind of went on down like that. How would the game and the bots interact? The game engine and the bots. Well, we could use some APIs. What would we do if bots died? Well, we talked about how we could make that work in terms of state persistence. And then ultimately, how would we achieve this scalably? Well, we figured if the engine could drive all the things, if the engine could be the source of truth, then that would result in sort of a centralized model that we could then scale very easily. So we went down that road, and then the architecture actually scaled very well as we added more complexity. So as we came around to realizing we needed something that would, ideally partition players into their Slack rooms, their private rooms with their teammates, and we needed something that would invite them, and we needed something that would perform help functions. So as we did all of that, we had a light bulb moment where we just sort of added additional bots for each of those functionalities, and ultimately we ended up with a slew. I think we had 6 or 7 bots by the end, but it was a beautiful model that scaled very well. So at the end of sort of our conversation-driven design session, we had basically 2 pieces. We had the game engine piece, which would hold the API, all the interaction logic. When the players would communicate, the engine would synthesize all of that, render responses and such. And then we had a slew of bots, and the bots would ferry actions and messages back and forth from the players to the engine and facilitate any other sort of gatekeeping actions that needed to be performed during the game. One really key technical decision that we made early on was that Slack would be the only player interface to our game. And this was key because this significantly reduced the threat surface of our game engine, because we wouldn't be exposing the engine to the players. We wouldn't be exposing the engine to the internet. It could reside safely inside our virtual private cloud. And then the only way players would work with it would be through Slack. So we could sort of stand on the shoulders of all of Slack's mitigations and all of their controls around people doing nefarious things on their platform. We could benefit from all of that and just focus on our game content, which was a huge productivity boost for us. So here is a really high-level architecture that we ended up with. It didn't start this way, but like I said, it meandered down a good growth path. So we actually started with a registration site. We got that up first so that we could start getting teams registered and get a sense of how many players we would have. And then we built the game engine and the bots in tandem, and those ultimately deployed together. And then on the eve of DEFCON, and actually in the morning of the game, we did a wild manual migration from the registration app up into the final game engine. We would have loved to automate that also, but again, timelines and deadlines, you can't always automate all the things. You got to sometimes use the elbow grease, and that's what we did. So manual conversion there, and then we were ready to kick it off. And you can see here that the bots actually talk out to Slack. Slack, there's no hole in our cloud coming inbound from that side. The only holes open to the public are the leaderboard for the game progress and then the original registration site. So a really high-level architecture for how Kevin and I work together is we basically threw up a shared document and came up with an API contract. So that way we could work in true tandem. We could work in parallel. I could be working nights, he could be working days, whatever. and I knew what my endpoints were. He knew what the endpoints he could count on from me were, and we could both iterate that way. So we came up with, I think we had about 7 endpoints. We had player management endpoints. We had actually, obviously, the endpoint for like a player submitted a guess, is it right or not? Team management endpoints, things like that. And one of the most interesting, which actually sort of evolved organically, but became a huge piece of the game, was the hints endpoint. So as Kevin alluded to earlier, we wanted our CTF to be different. We didn't want to have the conventional game where you get to the third of 12 flags and you've never done audio steganography before, so you get stuck and that's it. Your game is over. We didn't want that. We wanted players to actually have the opportunity to actually learn and progress and keep progressing through our game. And so if you got to a flag where you weren't familiar with the technology or the technique, we instrumented this sort of hint scheme, this time-based escalating hint scheme where if you were on a flag and you were stuck for a period of time, eventually the handler would start to give you hints, very general at first, and then incrementally more specific as time went on and as you still remained stuck until you were able to progress. And that was actually really cool because we're big fans of like sharing knowledge and bringing everyone up together. So teams and players could actually learn as they went through our game, which was awesome. And also no one would get stuck. So ultimately teams could keep progressing. And that truly made the game experience unique for each team because each team was essentially playing their own bespoke game where if they would run into problems, they would get hints. If other teams just blew through a flag, they never knew the hints were there. So it was actually really neat and it made the game truly sort of tailored to each player's experience. Here is a quick snapshot of the production logs and the actual route code up top. We used a lot of Go standard library packages, which was great. I'm a huge fan of that. We used a couple of choice third-party packages as well, HTTP router for performant route muxing. We used GORM for database persistence, which is great. And then I used a really conventional sort of middleware wrapping pattern where we would just wrap in functions like logging and authentication into our routes. So here's an example of the routes that I mentioned for the bots. And then at the bottom, you can see the actual production game day logs. And they were pretty chatty. There was a lot going on all the time, but Go handled it like a champ.
So as we were going through this, Alex generally focused on the back end. I focused on the bot portion of it largely. I was really inspired by just RPGs and, everything from like Dungeons and Dragons to MUDs and thinking about, how this interaction would take place. And, we had our essentially handler bot, which you can kind of think of like the game master bot running the game. But as we broke things down, we realized that I'm a huge nerd for the Unix design philosophy of, you write a piece of code to do one thing and you do that thing really well. So pretty much every like single task within the game had its own bot. And that allowed us to, not have to worry about things like state issues. That was a big thing that we were, stressing about when we were coming up with how we were going to design the game. It's like, well, what if a bot dies? How does it get its state back? What are there other dependencies where a bot might be relying on another bot for state? Eventually, we decided to just throw it all away, and we stored state in the database itself, and the bots were essentially stateless. And we didn't have any die, fortunately, but if they did, right, we would have been able to recover the game really quickly.
For sure. And here's the 6 bots and their API contracted routes that they ultimately mapped to. So again, we had bots for provisioning the team Slack channels, for provisioning the players, for putting them together. And then actually a bot to start the game and throw out the first flag prompt to the teams. As we were considering, so we're going to build this game, we're going to build this whole engine, we're going to make this integration with Slack, we recognized, happily, that we might be able to reuse some of this in the future, but we didn't know that we wanted it sort of coupled so tightly to Slack itself and their APIs. So we had the foresight to build sort of an abstraction. So we built a platform, we call it the platform abstraction. So the platform would be the interface that players interacted with. That was Slack this time, could have been SMS next time, could have been Telegram, Signal, any number of avenues for players to interact with the omnipotent handler that was doling them out breadcrumbs and clues. So we built this platform abstraction and we built an implementation for Slack. And we, using dependency injection, we injected that into a sort of agnostic bot base that was also an interface. And then we used that starting point to tailor out functionality for each of the individual bots that we need. And again, that was really scalable because we had this bot base, we had all of this set up, and anytime we needed another bot for something, we would just spin up another one. So here is a quick snapshot of the platform interface. So we had a start and stop method on the platform to kick off any like real-time API message queue interactions or things like that that you would need. Like we use Slack's real-time messages API for this case. And then we had sort of families or groups of methods for the individual bots. So we had, for the check answer bot, we had a method to get the next sort of message from players. You know, it would block until a player's message was ready on the line, then it would come through. And then we also had a method to send messages back to the player like, hey, yep, acknowledged, got your message, or nope, this was wrong, or yes, this was right. And then we had team assignment bot methods, player invite, player assignment, etc. And so any platform implementation just had to implement these. Then over on the upper left of the screen, we actually have the bot base struct, the agnostic struct. So the bot, every single bot essentially let the platform be injected into it so it could interact with the platform. Had a game configuration injected into it as well, so it would know the nuances and specifics of the game and specific messages and things like that that the game would need. And then it also had a little trick that I picked up somewhere along the way writing Go, an error handler function. So you could inject an error handling function into it. So any errors that the bot had would bubble up and out through your injected function, and then your application could route them wherever, handle them however you wanted, centralize them in that way. So you could manage errors however you saw fit. In the lower right here, we have arguably the most important bot of the whole game, the check answer bot. We have the start method. And so the start method of the bot actually just initialized the adapter called the start method on the adapters. In this case, it started the Slack real-time WebSockets API connection. And then it basically looped over a channel of messages. And anytime a message came through from, example, the Slack real-time messages API, it would process that message. So it's basically just a giant loop bot. And then when the check answer bot got a message from Slack, it would actually run through a function like this. And since this game was production grade, we knew that we had to do a lot of like error checking and making sure things were going to be safe and secure, especially given DEFCON. So we had a lot of really specific checks like, is this message exceeding some given length? Is it too short? Things like that. So at the top, you see a message length check. Then the next block of code is we actually acknowledge that we received a message and we send the acknowledgement back to Slack. So the handler bot says, yes, thank you, team, I got your message. And then we actually start forming the response. We actually initiate a call from this bot to our game engine API to check this player's answer submission. And then when the game engine comes back with a response, you know, that might be, yes, it's right. That might be, no, it's wrong. The bot is, again, stateless to Kevin's point. So it doesn't really care. It ferries that message back to the Slack platform and sends it on down the way. So then if we go to the other side of the house, now if we go over to the game engine side, this is the endpoint handler function for the check answer endpoint in the game API. So the game engine is sitting, waiting, always waiting. And as one of our bots comes through and sends a Slack message from a player, this is what's invoked. So this does, again, a bunch of checks, make sure the game isn't finished, the team's not banned, the guest isn't blank. And then ultimately it goes through, drills into the game state that it's maintaining for all these teams, finds the team, finds the player, finds their current flag, and actually finally does a check to see if this submission was correct. And then if it's not correct, we short circuit, we send back a nope, this is wrong. And if it is correct, we do a bunch of bookkeeping and things like that, where we maintain the state of the game. We increment the player's team's flag that they're on. We reset some hint timers, some flag timers and things like that. We persist all of that to the database. We actually fetch the next flags prompt, and then we send all of this back to the bot, which ferries it on to the player. So they see, yes, you got the right answer. You're on to the next flag. Here is the next clue or whatever. So now I'll turn it back over to Kevin, and we will actually hear about how the game went down at DEFCON.
All right. Thanks, Alex. So the event itself was amazing overall. And, we had been working on this for so long, and we didn't stop working on it until it was done, really. This picture here is us flashing special firmware on a whole bunch of Adafruit circuit playgrounds that we were giving away as badges to get into our party. We chose this particular PCB because we wanted to give players something they could hack on, and there's already tutorials and stuff. It's always such a bummer when you get this really cool electronic badge and you don't have a JTAG or whatever to be able to hack it. So yeah, you can see here that little keyboard in the bottom right-hand corner is the one I ended up giving away. Shout out to any Plank fans out there. So yeah, this was the day before the event itself, and we were still just constantly grinding and trying to get stuff all put together.
And I love this picture because it's wonderful to hear the story about writing the code and actually running it in the real world, but the work that goes in behind the scenes, I love that it's captured here. There's just grinding through bag stuffing and making all of these and getting all the orders filled, and Kevin designing the logo and the stickers and putting the clips on every badge. That was, the behind the scenes that went into days and days of preparation for this with bunches of volunteers to make this event happen.
Yeah. And when you have such a strong technology platform and like the backing technology like Go, that you can trust, it gives you a little bit of flexibility and freedom to focus on, what I would call the sugar of the game, right? Like a cool logo and stickers and stuff like that. So this next picture here is Blake and I, manning the booth at DEF CON. You can actually see in the background that guy in the scary mask. We had a trailer made for the game. We contracted some students, and they made us a trailer, which was really cool. We have a bunch of flyers there. So this is where we sort of ran the player interaction portion of the game from. We had someone sitting there during the event, so if players had issues, they could get assistance there. And all right, so let's move into the timeline of how the game went down. So the night before, we had, threw a party for our local hacker group, DC480, and we're hanging out, and we realize the last minute, we don't have a leaderboard yet. We had used leaderboards in previous years, and it was awesomely successful because players could come down and see, how things are going. If a player thinks that a flag is impossible, they can now check the leaderboard and see like, nope, actually, this team has passed a certain point. So, they know not to give up. And it was just really good for spectator interest as people were walking by and they would ask people manning the booth, like, oh, what's going on here? And they could use that as a visual aid to explain. So Alex actually stepped up to the plate, and in the middle of a party, while we're all hanging out and having a good time, he built the actual leaderboard. And this is what it looks like here. You can see this is actually a screenshot from the end of the game, and you can see, the winning teams and watch as the teams progress through. It was awesome to see this put into place. So a huge shout out to Alex for getting that done. Now, the actual day of the event, August 11th, it was so exciting. A lot of roads led to this day for us. So during, data migration, we hit like some small snags and things that we worked through, like nothing too crazy. The big problem was the code I wrote to do check answers had a blocking condition that I just didn't see. Right, we never tested at the scale that we were actually running at DEF CON, and so we were writing code and patching the game engine until 8 minutes after the game launched, which was suboptimal and terrifying. And we also had a wombo combo of issues where we sent out way too many invitations for our Slack instance, and we got rate limited. We were able to reach out to some friends who work at Slack, and they were able to help us out, but that was kind of an existential event for us, which is terrifying. This picture is one of my favorite pictures of all time. It's Alex and I were chilling in robes on the suite we were staying in, and I probably wrote the best, 15 minutes worth of code I'll write in my entire life. I don't know how I did it, but in that time, we were able to just patch the game and get it running really smoothly, which was nice. Then if you look in the background, you can see some of the rewards that we had waiting for us later after we finished the game. All right, so about noon, early progress. we had an issue where there was a unforeseen information disclosure vulnerability in GitHub that was giving players an answer that was technically correct, but we didn't account for. They were supposed to find one email address using a certain method, but they were actually finding another email address, which was technically correct. So the great thing about having the game engine the way that it was being stateless is we were able to push a change to the appropriate answer section in the database completely seamlessly. No one knew that there was a change, except for the one team who we let them know that that was correct, and we incremented their flag. And multiple other teams ended up submitting that same correct answer later. So being able to just quickly hot patch the game content was huge. It is DEFCON, right? We had to think about abuse and protections of the game engine and countermeasures. So we had things like rate limiting, checking the size of messages. The first team that registered for iCTF, their name was single quote or 1 = 1 semicolon dash dash, right? So that's the kind of people who we're dealing with here. And we did have to ban one team, but it was really cool because our anti-exploitation countermeasures actually worked. We were able to ban them and get them out of the game, and so they couldn't impact the game anymore, which is great. Coming towards the end of the experience, when people were starting to reach that human intelligence portion, it was awesome because we had no technical issues during this time. After we had our little patching in the morning, the game engine ran really smoothly, and we were able to just focus on getting the players through the game and having a great time. And coordinating the human aspects of the final stages of the game was really stressful. And I just really love that with Go, we were able to just set the engine to go, and it worked, and we didn't have to worry about it, so we could focus on the people. Here's an actual map of all of the volunteers that we had moving around, right? So, like the red dots there are a path, right, that one player would have to take. The blue dots are another one. We had various people. We had what we call game wardens, or people just sitting on the floor who were part of the game, but you never would have known. They were just watching to make sure that the players and participants and volunteers are all safe and that nothing went wrong. And it was amazing to watch all these pieces kind of coordinate themselves or be coordinated, and while the game was still going. It was just amazing. And finally, at 4:30, we called it. It was game over. Only one team actually made it through the entire game, which isn't surprising because some of the later flags were pretty difficult. And we gave out tons of prizes, hundreds of shirts, I think like 1,000 stickers, and then just an insane amount of stuff. And we had a gigantic party, which was a nice reward for ourselves. And we finally actually slept. I didn't realize that, for several months, I just wasn't sleeping that much. I was working on iCTF pretty much every night. And that first morning when you wake up after completing a really big project, there's a lightness, which is great. And there's also this really significant sense of accomplishment that, this was an idea a year ago. And we came together as a small team and we delivered an experience that was way bigger than we had any right to deliver. And it just worked out so well. And choosing Go as our language of choice was a big part of that because we're able to just create things almost as fast as if you're doing it in something like Python, but you had more of the resilience and scalability that we look for in a lower level language. This picture here is us at the booth at the end of the day, just a huge crowd of people coming to get their shirts. We're giving stuff away. The energy was absolutely incredible. And to think that, again, just some random idea that we had became iCTF and interacted with hundreds of people's lives was cool. That was really amazing. So we'll do a quick postmortem, kind of hit some quick points of the things that we learned, and then we'll open it up for questions. So Alex, you want to start us off and we just talk about these real quick?
Absolutely. So the key sort of takeaways that we had when reflecting on all of this was, the choice of Go, as Kevin mentioned. Also, the design allowing our small team to sort of monitor all player and handler interactions. We actually could assume the role of the handler, entity at any time. So as teams were asking things or conversing, we could actually intervene in the pre-programmed game content and actually provide any other context that was necessary, which again helped to make the game even more immersive and interactive with players with actually very little actual input on our side and time on our side. So really outsized benefit. having the ability to modify game content, as Kevin mentioned, we could change hint timings, we could change answers or things like that, and it would all be reflected in real time as teams came to that point in the game with no restarts or downtime, which was great. Our application design, which again, we were both really, really happy with. It scaled very well. It provided us, the visibility that we needed to make sure that things were safe and functioning. We had the focus. The first part of the morning, as Kevin said, was basically like glued to the terminal screens, making sure that everything was running. And after 10 minutes, 15 minutes, you start to think, oh, maybe this is going to be okay. And then after an hour, it's like, oh, this is good. And things started coming in. Players started getting into the human portion of the game, or coordinating volunteers and actors became a bigger focus and suck on our time, basically. So being able to divert our attention to that without having to worry that the game was going down every 8 minutes or something like that was really great. And last but not least, we came away in hindsight with a reaffirmation that running an event is very difficult. Huge kudos to, for example, the GopherCon folks for doing this, because people can get crazy when events are going down, and especially when you have, for example, a lot of money on the line.
Yeah, absolutely. And I was about to say before we close out here, this will not be the last iCTF event. We were actually planning on running one this year, but COVID happened. So if you're ever at DEFCON, look for iCTF and come and say hi to Blake, Alex, and I. And yeah, so thank you so much, GopherCon. Wish we could be there in person. Hopefully we'll be there, sometime at another conference. And yeah, thank you.
Yeah, it's been great, guys. Thanks again. So we'll see you all next time.
Bye.